Some of you might have seen we have a special guest with us out there in the cloud showcase, IBM's Watson. And there's a little rumor flying around that 5 people last night beat Watson. I don't have any proof, but it's certainly going around. I'm not sure if they fed Watson drinks or what happened, but maybe our next speaker can confirm. So I want to welcome Stephen Gold, who is Director of Marketing for Watson Solutions at IBM, is going to talk about Watson in the cloud. Here.
Great. Well, good afternoon. I guess it's still good morning. It's a pleasure to be here today. What we want to do is take a little bit of a journey in the next 20, 25 minutes or so and share with you a little bit of the insights of what really catalyzed bringing Watson to market, what the implications are of Watson in next generation computing, and really how it will manifest itself in the form of the cloud and the implications on the cloud. So let me set the stage a little bit and ask everybody a question. How many here have heard of Watson? So we're going to make this interactive. We're going to have a little fun this morning. Great. So Watson had a 70% unaided awareness among the American populace. So when you go to the average person, 7 out of 10 people knew Watson, and they knew Watson for what? Jeopardy, right? It won Jeopardy. It accomplished something no computer had ever accomplished before, right? Which was really unusual. It navigated the complexities of human language. It basically calculated and evaluated a set of responses, and then it presented the responses and buzzed in. Now, in the case of Watson, it was evaluating about 200 million pages of data for Jeopardy in 3 seconds. Anybody know why 3 seconds? It was a time that it took Alex Trebek to read a question, and you can't buzz in before you read the question. So Watson really needed to be at a point 3 seconds in that it could either affirmatively buzz and answer the question, or determine based on its algorithms that it didn't know enough or wasn't confident enough relative to its position to go ahead and buzz in. There we go. So what I want to do is I want to go ahead and start the presentation, if we can get this to move. Terrific. So let me set the stage a little bit. There's no question that our world is becoming more instrumented, interconnected, and intelligent. Imagine walking out of the airport, hopping in a taxi, and that taxi is on the grid, right? It has visibility to traffic, to congestions, to accidents, to patterns, and it instantly gets routed for an optimized path to get you to your destination. What happened? Well, one, you got to your destination most efficiently and effectively, lower cost. That cab will pick up another fare much quicker, which is benefit to the driver. Lower carbon emissions, because it's not sitting in traffic and idling, and lower fuel consumption, right? That's a situation where information is being used and utilized in a way for a better outcome. And a lot of the talk this morning is going to talk about ways in which we can use information. And we're going to go ahead and use that word big data. And actually, I was corrected, just so you know, from our information management team. They said, Steve, you don't say that right. They said it's really big data because it's big. Now, I never knew we had small data. But the idea being is that we can take unstructured information and we can put it to work in ways that we can get to better outcomes, very much like what happened in the taxi cab. Now, we're highly interconnected as well. In fact, I was reminded the other day just how interconnected we were. I got something in the postal mail. I opened it up. It was from a municipality. It was a citation. And it had to do with a moving traffic violation. And at first I panicked, and then I realized the good news is it was my wife. So looking at that, I recognized that I could go online through a link, look at the actual violation occurring. The camera had taken a picture of my license, it had processed the license through the DMV, and it issued an invoice, a citation, which came to me via mail, and then it would reconcile upon payment and close out that record. Right? That's a pretty sophisticated set of steps, and we have today 1 trillion interconnected devices that are out there, 2 billion people on the web, 5 billion mobile devices in activity. All of this doing what? Driving additional information. And in fact, information is becoming the new oil. Ann Widblad was quoted as it relates to this particular statement. Ann's a noted venture capitalist in the Valley here. And I thought it was pretty insightful because if you think about, oil in the ground doesn't have a lot of value. It has value once it's taken, removed, and refined and applied for a specific purpose. Information has that same implication. It, in and of itself, isn't all that interesting. Big data isn't all that interesting. What you do with big data, how you apply unstructured information, how you take text and blogs and emails and make it work to your benefit, that's what makes a difference. And there's a lot of data. 1.8 zettabytes, according to IDC, of data this year. Right? 249 billion emails happening every single day. 2.5 quintillion bytes of data produced every single day. That's a lot of information. That's a lot of opportunity to gain new insights into information. And in fact, what's happening, it's ushering in a whole new era of computing. 100 years ago, when IBM began, it was in the tabulation business, among other things. So tabulation accelerated the process by which the census was taken. You know, the next iteration or generation of computing came around the 50s with programmatic computing. What we really know today about applications, you know, earlier on it might have been Fortran and Pascal and BASIC, COBOL. You know, today Java, C++, other developmental languages. And it's what largely we think about when we think about computing. The next generation of systems will be learning systems. Systems that aren't programmed, systems that are taught. Systems that get smarter with each iteration, with each outcome, with each new piece of evidence. They're more capable of providing insights and action. Now, when we look at the characteristics of what's changed between the programmatic computing and learning system, you know, there's some marked, notable differences that are important to distinguish. One, this whole idea of search versus discovery. Now, we're all familiar with search. We Google. We get a response. I don't know if anybody pays attention anymore, but you know, it brings back millions of response. Anybody here get past page 30? Right? We look at the top 2 or 3 responses. They may or may not be relevant to our search. We may key in a couple of new keywords, but it's not content and context. Right? As an individual, I still have to work at it to try to find the information I need. Next generation learning systems will be about bringing back relevant information, about putting that relevant information in a context to weight it as to what the likelihood that is the right response. Which gets us to the second point of deterministic versus probabilistic. Deterministic applications give you a finite answer. 2 plus 2, clearly it's 4. Well, Watson's a humble genius, right? In the case of Watson as a learning system, Watson would say, well, you know, I think 2 plus 2 may be 4. I'm 90% confident. But I also understand 2 plus 2 could have other implications. It could be a car configuration, 2 front seats, 2 back seats. It could be a reference to a family unit, 2 parents, 2 children. Right? It's a poker strategy. So 2 plus 2 actually has more possible outcomes. So probabilistically, these systems will be able to assess and evaluate exactly, right, what the probability is that that response, not an answer, that response is correct. We move from machine language to natural language and navigating human speech. And then we move from this idea of a system of record, which we've all heard about for many years, right? Who owns the data? Where does it belong? To the system of engagement, right? Bringing these applications to the point of impact, empowering line of business to act in ways that they haven't previously been able to act. Now, it was about a year ago that Jeopardy played. It was actually in February of 2011, February 12th to be exact. 34.5 million people came to witness. Everybody says, but IBM clearly knew it would be victorious, and I can tell you nothing was further from the truth, right? Happy at some point to show you the mechanics that led up to Jeopardy relative to Watson's progression and its learning, and it was clear that over the course of 4.5 years, it had improved pretty dramatically, but there was no clear indication that it would be victorious, right? So we all held on with bated breath. Now, this also replayed in October, and it was amazing. 14.9 million viewers came and watched the rerun. I have to tell you, Watson still won, right? No changed outcome. But it shows you the level of interest that was out there among the audience to understand what happened. Now, for those that don't know, Watson actually began in a bar where I understand a lot of great ideas often originate. And what happened is a group of IBMers were sitting and having dinner, and literally everybody got up from the restaurant section and went into the bar. And they were curious, so they kind of followed everybody in. And what they saw on the TV screen was Ken Jennings, who was the longest winning streak champion for Jeopardy. He had won 74 consecutive games, and he was, I think, on game 72 or so at that point. So everybody went in, and that was really the catalyst that got people thinking, wow, what if a computer could do this? Now, once every 10 years or so, IBM takes on a grand challenge. Previous to Watson, the grand challenge was the chess-playing computer, Deep Blue, and its competition against Garry Kasparov, right? And so the idea isn't at that point to commercialize as much as it is to evaluate and demonstrate whether or not a particular idea is feasible. In September of last year, we announced both the commercial initiative to bring Watson from Watson at Play to Watson at Work and to commercialize it. We announced a partnership in healthcare to build out applications centered around medicine. We announced our first customer, WellPoint. WellPoint, you might not know by name, but they're the largest health plan provider in America. They insure 1 in 9 Americans. You probably know them as Blue Cross Blue Shield, either the Anthem or Empire Network. And they saw the benefit. They said, look, clearly we're in an information-rich industry, right? Speed and accuracy are of critical importance to getting to better decisions. We believe the opportunity here is great to apply a Watson technology to healthcare and to medicine. Just recently, we announced that we're extending the reach into financial services with Citi. And we'll talk more about that in a minute. And clearly, the plan is to continue to proliferate the use of Watson into new industries, into new use cases, and into the hands of new users. Well, we talked a little bit about the fact that there's a lot of information coming out. In fact, 90% of the world's data was created in the last 2 years. Think about that. From the beginning of time to now, 90% of the data, within 2 years. 80% of that or more is unstructured. Right? Most of that resides in the public domain. Right? Now, certainly there's unstructured data in an enterprise. It's in the call center and various notes and focus groups that may have been captured. But all the tweets, the blogs, right? 12 terabytes of tweets created every single day. Right? Tremendous amount of information being created out there that has value, that has insights that can be gained. You want a 360 view of the customer? What if you could take the totality of all information and put it in context of that particular customer to get that view? That's much more powerful than just looking at transactions or just looking at internal behavior of that client. You're looking at the ecosystem that client or customer ultimately participates in. Now, despite the fact that we have a lot of data and despite the fact that I think we're getting better as a community at dealing with unstructured, the majority of systems in place today don't take advantage of it. They weren't designed to take advantage of it. They're programmatic in context. They're ERPs and CRMs and supply chain solutions, and they serve a great purpose, but yet they're really not capitalizing on the newfound wealth, that new oil, if you will. And in fact, when we talk to CEOs and CIOs and CFOs, when we look at studies from MIT and others, what we hear organizations say, what we hear CEOs say is, hey, I can't get the information, or I don't have the information I need. Or if I have it, I can't get to it. Right? So there's a big impetus here to figure out how to take the information, put it into the right place at the right time to make better decisions. And part of that is clearly analytics. And I know the last speaker talked about the importance of analytics. Right? Analytics is an opportunity to unlock insights into big data. And in fact, Watson is a new class of analytical solutions. So we absolutely embrace and see the importance of the next generation and application of analytics. But when we think about Watson, which is actually a system of systems. So I always get asked, what is the breakthrough technology that's in Watson? Well, it's not a breakthrough technology. It's actually 41 different subsystems that have been brought together. And when you look at the respective subsystems, the majority of the technology has been around for a long time. But if there were 3 things that really differentiated Watson from a technology point of view, one would be natural language, the ability to navigate the complexities of human speech. Now, it's not speech recognition, because it's one thing to understand, it's another thing to understand and put it in context. Right? We speak in sarcastic tones, we speak with colloquialisms, and we speak in different ways, and that's very hard, and we'll talk about why, for a computer to understand. So that's a significant step forward in the application of natural language. But that by itself doesn't define really what Watson does. The second part is Watson has the ability, once a input has been provided, a question, to break it down into all of its subcomponents. Semantically and semantically, it breaks it down. And it looks at all the possible ways in which that question is being expressed to truly understand what is being asked. And it forms a hypothesis. And from that hypothesis, it then goes and evaluates against the evidence and data what the possible responses would be. And it weights those possible responses. And for those that saw Jeopardy, you saw an evidence panel. And we give you the degree of confidence it had in each of the answers. And what's interesting, and I always get asked this question, but what if the data isn't good? Well, Watson's not trying to get to an outcome that's good or bad. It's trying to get to an outcome that's actionable. If it provides a response and the confidence is high, but the action taken is different, it learns. It now knows, right, that there was a different course of action or a different outcome taken. And with each iteration, it's getting smarter. And that's really the third piece here, is Watson's ability to learn. So why is it so hard for computers, right, to navigate the complexities of human speech? Well, in this first example, what you see is a simple question. Where was Einstein born? If it's stored in a structured format, rows and columns, quickly can be retrieved, and the answer would be obvious. But if it's embedded in a narrative, like this particular statement that one day among his city views of Ulm, Otto chose a watercolor to send to Albert Einstein as a remembrance of Einstein's birthplace, all of us in this room say, well, it's obvious. He was born in Ulm. The computer is looking and say, well, it's not obvious. That's an inference. Right? So what's normal and natural for humans relative to how we think and process information isn't aligned, as you all know, normal and rational for a computer. So to get it to a point where a computer can understand an inference was challenging. Take the second example about who ran this, and you look at the statement, if leadership is an art, then surely Jack Welch has proven himself to be a master painter during his tenure. Most of us, if we were literal, would infer what? Jack Welch was a painter, right? Because clearly that's what it says. It's literal. So again, the ability to decipher this, put content in context, and understand how to interpret this was a formidable challenge that was taken on by the research team. Now, if I take this and put it in context of why we as individuals care, let's take the example of healthcare. So, individual completes the undergraduate, heads off to medical school, will spend 5 years in medical school. Between the time they start and the time they finish and graduate, information in the medical industry would have doubled. Now, I'm reasonably comfortable that individual isn't going to be able to keep pace with the rate of information and the doubling of data that is available, let alone the fact that there's 75 new clinical trials that start every single day and countless research reports and studies and articles that are written. They stopped cataloging medical articles a couple of years ago, and the count was over 10 million. Right? So from a practical point of view, I can't expect that learned student going through the medical program is going to be able to consume and keep up with the information. In fact, when doctors were surveyed, right, 81% said I spend 5 hours or less every month reading periodicals. Now, put this in perspective. I was sitting in the waiting room the other day, my doctor, and I looked around. There's about 10 people waiting to get in. And I remembered something statistically that 1 out of 5 or 20% of the diagnosis of those people would be wrong. And I'm thinking, wow, I have a 2 in 10 chance of being misdiagnosed. Now, it may not be life-threatening, but think about the implications of that, right? Misdiagnosis means misapplication of treatment, which means I probably won't get better as quick as I could, right? It's inefficient, it costs money, I'll have to return to the physician, nobody's happy. What if we could advance that and get to a point where first time through, right, we actually yield a better outcome? So how does that happen? Let's take a look at a 58-year-old woman who presents at a doctor with a set of symptoms. So she complains of dry mouth and dizziness and a number of other symptoms. And right away, Watson goes to work, and it starts to build what we call a differential diagnosis. It's looking at the input and saying, hey, based on what I know, it looks a lot to me like this particular woman has the flu, influenza. But very quickly, the doctor starts to iterate and say, well, tell me, do you have any headaches? Do you have any back pains? Are you coughing? And with that additional information, Watson recomputes, reevaluates, and resets, and now says, based on what I now know to be the case, it looks to me like this could be a urinary tract infection. Now, the confidence still isn't high, right? Because there's not enough data yet to boost the confidence in the Watson system. So what we do is we take additional data points. Now, these data points might be coming out of a system, like an electronic medical record system, an EMR system, or a patient system. They aren't necessarily based on pure interaction. So there could be multiple feeds in, multiple data sources. It's evaluating this. Based on family history, right, we see the differential diagnosis shift to diabetes. We look at the patient history, and all of a sudden, our confidence around UTI has increased, although diabetes still looks like a likely suspect. I ask about the patient's medication, or maybe I know about the patient's medication. It introduces another variable in terms of what the possible diagnosis could be, esophagitis. And finally, we perform a simple test, right, to confirm that, in fact, UTI, right, is the proper diagnosis. Now, from there, Watson can move forward understanding if that's what the clinician indicates that they're in agreement to, what are the options relative to treatment? Now, for those that have any medical training or have had these symptoms, you might say, oh, it's easy, it's an antibiotic. But which antibiotic? Which one's most effective? You need to consider things like, is the patient in this case pregnant? Right? Are they allergic to penicillin? Right? So there's a lot of dynamics relative to the free flow of information that influence exactly how this works. So today, right, we've moved beyond the concept into the reality. Watson exists at WellPoint. It's basically in pilot on its first use case. In other words, the first application of Watson. It's around the review and assessment of pre-authorization treatments. So if you go to the doctor and the doctor prescribes a battery of tests, a clinician will review that request from your health plan, right, to ensure that you're getting the proper course of treatment, or if there's alternatives, to perhaps make a recommendation back to the physicians to consider, alternate tests or additional tests as may be prescribed. We've fed 25,000 cases already into Watson to train it, because again, it's not programmed, it's trained, it's got to learn. And they're now at a point that they're actually starting to run real-time cases through the system. So we'll move from pilot into production later this year. So it took 4.5 years to move Watson through to a point that it could actually be successful at Jeopardy. And remember, that was a purpose-built system. So what you saw at Jeopardy was one user, one category, one question. It was stateless. It didn't remember what happened a couple questions ago. To a system that in less than a year will go to production. It's concurrent, right? It stayed full. It's iterative. It's ingesting a greater form of disparate data and sources. And in fact, we've started to work on our second use case. We announced a development partnership with Memorial Sloan Kettering. Many of you may know Memorial Sloan. It's probably the preeminent cancer care center in the world. They have 20 years of patient histories, millions of records, and they're going to be collaborating with us on building an application around the diagnosis and treatment, at first of lung cancer, then we'll advance to breast cancer, and then we'll advance to prostate cancer. And the plan is, over the course of time, is to build out these specific applications. We also announced, as I mentioned earlier, that we've entered financial services. Now, all of us have probably had the experience at one time or another of calling the bank, our financial planner, the wealth management department, and asking a simple question. Hey, I have some money and I'd like to invest it. Right? Or I need to make a decision about a mortgage or a refi, or a home equity, or I'm wondering about credit card services. Now, the challenge there is, again, lots of information, right? 9,000 new articles coming out of Reuters every day, millions of trades happening, right, every minute, right? 5 new research articles coming out of Wall Street every minute, right? And now I'm talking to my financial planner and say, where should I invest my money? Right? Let alone the fact that a lot of the insights in terms of possible investments are locked away in footnotes. Right? We've all gotten annual reports. Maybe we've looked at a 10K or an 8K or a 10Q. Right? All the good stuff is buried somewhere in that report. Watson very quickly can ingest, understand, and put content in context to help as an assistant. As it did in medicine, it can help as an assistant in financial services, solve the problem. So we're at work today at Citi on the consumer banking side. We have other customers we're working with on the institutional side of the house. And clearly the goal is to continue to proliferate places and applications in which technology like a learning system in a Watson can be put into effect. Now, behind the covers, this is really what Watson looks like. Now it'll start to get interesting for the folks in the room. Because one of the things we're doing is we're creating, obviously, an industrial style solution. It's based on actually a number of platforms. There's a data platform which allows us to manage the information, to train and to curate content. There's an analytics platform. And then there's the Watson engine. Watson engine has things like the natural language processing techniques, the algorithms and annotators that are required. And then ultimately what goes out in front of a user is a Watson-enabled application. That may be an independent application. It may be integrated into an existing application. But you can start to see it has a common construct to things that you're familiar with. So why is that interesting? Well, ultimately, what will happen, and we want to happen, is to open up these platforms, publish APIs, provide toolkits, right, to invite the community to start to develop, right, in conjunction with the work that we're doing. Now that gets really exciting, because then we get the brain trust room and beyond, right, to begin to leverage, take advantage of a whole new generation of opportunities and ways in which organizations can begin to put technology forward. Now, Watson will be delivered as a service. It'll be delivered as a service through the cloud. Why? Now, is it because we're at a cloud conference? No. It's because it makes sense. Watson's a little bit different. Number one, if you think about the example in medicine, one of the things hopefully that struck you is, wow, if Watson can actually improve the diagnosis and treatment associated with oncology cases, wouldn't we want everybody who practices medicine and that type of medicine to have access? Whether it's Bangalore, Beijing, or Bangladesh, shouldn't everybody have that same capability? Well, first of all, providing as a service makes perfect sense because we can extend the affordability of a product in a way that wouldn't manifest itself if it was physical infrastructure, right? And so we want to do that. We want to get the capabilities out there. We want to extend the footprint, right? We want to eliminate one of the barriers to entry. We want to make this highly accessible. And then the other part is we want to continue to curate content. I use that word curate, train. Taking information by itself doesn't help us. The training of that information does. Now today, each time we bring in new information, we have to take Watson offline. We have to train it and then bring it back. That'll change, right? There is a tremendous amount of development effort going on to advance the capabilities of a Watson. And what we absolutely believe we'll be starting at a point where we're curating content and getting to the point where we're ingesting new information in real time. Well, that works best if it's in an environment such as this. If I deliver it on-prem and I don't have access, then you're not benefiting from all the work that's being done relative to new content being collected and curated. So delivering it in this form, right, benefits the user, it enhances the value of the application, and it certainly speaks to the speed and efficiency and affordability at which we can deliver this. One other comment on the last slide, you saw off to the right there reference to public, private, and hybrid. And I always get asked the question, which one is it? And the answer is yes. It's early. We clearly see situations and use cases where it will likely be a public cloud. We see situations where it will be a private cloud. And maybe early on, what will be the most frequent use is a hybrid. Take healthcare, where there is common data in the public sector about health information that can be shared. It's commonly available. There is quasi-public information that gets licensed, like New England Journal of Medicine and articles, right, which is quasi-public, that can be shared. But there's also patient data and private information that likely will be stored, right, in a private environment. So hybrid opportunity really affords us perhaps the best of both worlds, where we can continue to curate and develop information and content as part of enhancing the application, but ensure compliance with things like HIPAA. The other part of this, and this is a little bit of mom and apple pie, I think if you're looking at cloud solutions, the benefit, remember we talked about bringing this directly to line of business. So who benefits from a Watson? Well, a physician who's interacting with a patient, perhaps a financial planner who's talking to a customer, a lawyer, right, talking to a client. Well, in bringing it out, what's one of the best ways to get technology into the line of business, right, is through a cloud. It's quick, it's flexible, it's cost effective. The application itself, and you'll see more of the Watson look and feel in the coming months, is intuitive, it's easy. There's no programming required. It's all natural language based. So the nature of learning systems lends themselves to usability, right? And the ability to leverage the cloud for speed and efficiency makes sense. The configuration of Watson on Jeopardy, it had 90 servers, IBM P750 servers, 2,880 cores, 16 terabytes of memory, 20 terabytes of disk. Anybody have that configuration here? Not exactly the typical configuration that the average office or enterprise is likely to have. Now, the specific use cases for the specific use cases that we're looking at are a fraction of that size. But still, let's take that out of the equation. Let's make sure through the cloud we can scale, if you will, dynamically up and down. All right. So we're getting towards the last couple of points I want to make here. One is the fact that from a Watson perspective, we had a lot of people come to us and said, I need a Watson. What we discovered is they really didn't, but maybe ultimately that's what they will end up with. So the aspirational outcome is I want to get to a Watson. What do I do today? How do I get ready for Watson? And here's where I think everybody in the room can play a pivotal role. There are a lot of things that can help organizations better prepare. I heard the term earlier in the presentation before mine, talking about master data management. Well, that's a great example. If you don't have data, or you don't know where your data resides, or you haven't taken the step to aggregate and pull it together, that's a really good thing to do. By the way, you probably have immediate benefit to your organization through that step in the process. And ultimately, when you go to a Watson, we're going to leverage and take advantage of that. And in fact, the way we think about this, if you've seen the IBM Smarter Analytics Framework, it's all around the idea of helping customers align their information, master data management, big data, big insights, streams. It's all about anticipate, what is likely to be the outcome through analytics, business intelligence, our Cognos offering and solutions. Act, putting information into the hands of executives. And then Watson here is really this learn piece. So all the things we need help with are helping clients align, anticipate, and act, and prepare for a Watson solution. Now, IBM has a rich history of partnering with folks in the room, of creating partner ecosystems. Here's a great example. Esri, who's a leader in geospatial systems and has an expertise there. We help partner with CloudTrigger. I know CloudTrigger is here today to bring analytics into the cloud. Combination of IBM and our capabilities like Pure Systems, right, brought forth a new offering. In fact, CloudTrigger just launched last week. So they're 3 years in. Congratulations to them. Right? We're thrilled to be working as a partner. And it's not just emerging or evolving opportunities. It's well established. If you look at Tatas here, they have a significant market share in Brazil, something like 49%. They're dominant in Latin America. They're a well-established ERP players, but they need to be more available, right? So partnering with them, bringing their applications out into the cloud, offering extensions through analytics and others, really has created a wonderful win-win-win environment where the win for the partner is obviously playing on top of the IBM platform. The win for IBM is having great partners. And the third win is working together to advance the application of new technologies like Watson. Thank you for your time today.